All right, today we're diving into a pretty radical idea. It's from a theorist named Masi, and it challenges, well, just about everything we think we know about how our universe began. So, for a minute, let's just set aside the Big Bang and imagine a completely different origin story.
It's maybe the biggest, most fundamental question you can ask. Our best science, the standard model of cosmology, it gets us almost all the way back to the beginning. But it hits a wall. At that very first instant, our understanding just stops. Our physics can't see past it.
And that wall? Well, that's what physicists call the singularity, a theoretical point of infinite density and infinite heat. But here's the catch. A singularity isn't a real physical thing. It's more like a flashing warning sign telling us that our theories have gone off the rails. It's the point where the story of our universe just goes silent.
So how do we get past that wall? This is where Masi suggests we need to completely shift our thinking. What if we stop trying to pinpoint a single moment of creation and start thinking about it as a process of emergence?
This quote right here is the absolute heart of the idea Masi calls quantum mirror-genesis. And that keyword emergence is everything. Think of it this way. A hurricane isn't just created out of nowhere in an instant, right? It emerges from a very specific set of conditions: heat, pressure, moisture. Masi is proposing our universe did something kind of similar, that it unfolded from a more fundamental pre-spacetime state.
Now, Masi is really clear about this. This isn't about throwing out the Big Bang theory. I mean, that theory works incredibly well for everything that happened after that first moment. This is a framework for asking what came before that moment. It's a way to start a new conversation right where our old theories just stopped talking.
Okay, so how does this whole quantum mirror thing actually work? Well, the model really rests on three core concepts. Together, they paint this incredible picture of how our universe might have unfolded. Let's break down the first piece.
First up is what's called the threshold regime. So forget about thinking of a single point in time. Instead, I want you to imagine a kind of boundary condition, a state where things get so extreme that our normal ideas of location and duration, they just dissolve. They stop being the fundamental rules of the game.
Probably the best analogy here is a phase transition, like when water boils and turns into steam. It's not just hot water anymore, it's a totally different state of being. So, as the very early universe approached this threshold, time would have stretched out, slowing to a near standstill, and space, it became delocalized. The very idea of here versus there just lost all meaning. The system wasn't in spacetime, it was the raw ingredient for spacetime. So what's happening in this weird pre-spacetime state? The model suggests something called mirror symmetry. Now don't picture a regular mirror on your wall. This is something deeper, way more abstract. It's a symmetry within the quantum state itself. Imagine a perfectly balanced but incredibly unstable equation that's just waiting to collapse. This internal duality, that's the trigger for everything that happens next.
Right, so that fundamental instability has to resolve itself somehow. And that leads to the main event, the quantum mirror collision. But again, this is not a collision happening in space. It's an internal collapse and rebirth, a kind of rapid self-interaction inside that single pre-spacetime system. And it's this incredibly violent redistribution of energy that actually forces spacetime itself to emerge from the chaos.
Okay, so as you can probably imagine, this idea has some massive implications for how we see the cosmos. If space-time itself is something that just sort of emerged, what does that really mean for our origin story?
Let's go back to that huge problem we started with. If this model is even remotely on the right track, what does it do about that impossible singularity at the beginning of time?
Well, it just erases it. Poof. Gone. In this model, the singularity never even happened. It gets replaced by a finite, physical transition. The breakdown wasn't in reality, it was in our math, in our theories trying to describe reality. The universe didn't start from some impossible infinity, it just transitioned from one state to another.
And this table here really makes the differences crystal clear. Just look at the initial condition. The Big Bang model is stuck with a classical singularity. Quantum mirror-genesis, on the other hand, proposes a physical threshold. What about space-time? The Big Bang just assumes it's there from the beginning. Here, it emerges. It's a fundamental shift from thinking of the origin as an event to thinking of it as a process, and it's a process driven by internal quantum mechanics, not by some kind of external inflationary force.
This also completely reframes how we think about cosmic expansion. It wasn't a violent explosion happening in space.
Instead, it's the geometric consequence of the universe organizing itself, literally unfolding its own structure out of a pre-geometric state. The expansion is the creation of spacetime.
Now, it is so important to remember this is a highly speculative idea. So, what's the next step? Masi really stresses this isn't supposed to be a final answer, but really the beginning of a whole new line of questions.
And that's the whole point. The goal here isn't just to have a cool one-off hypothesis. It's to build a coherent research program. It's about creating a roadmap that mathematicians and physicists can actually use to build on these ideas, to test them, and hopefully turn them into solid predictive science.
And this is basically what that road looks like. The next steps are huge, right? You got to build the rigorous math, you have to define that initial quantum state, and this is the big one, you have to figure out testable, falsifiable predictions. Could this model explain some of the weird anomalies we see in the cosmic microwave background? Could it predict new signatures in gravitational waves? That is always the ultimate test of any theory.
And this all brings us to one final, really powerful question. An idea like quantum mirror-genesis really challenges us to rethink our place in the cosmos. Was our universe an object that was born in a single fiery instant? Or is it a process, something that is constantly unfolding, constantly becoming? Not a singular creation, but a continuous emergence. Something to think about.